Graphing absolute value functions. Essential question: how can you identify the features of the graph of an absolute value function? That's what we're going to talk about in this lesson. Explore 1. Graphing and analyzing the parent absolute value function. Absolute value, written as the absolute value of x, represents the distance between x and 0 on a number line. As a distance, absolute value is always positive. For every point on a number line, there is another point on the opposite side of 0 that is the same distance from 0. For example, both 5 and -5 are 5 units away from 0. Thus, the absolute value of -5 equals 5, and the absolute value of 5 equals 5. And here's a little graph to show you. The absolute value function x can be defined piecewise as the absolute value of x equals x if x is greater than or equal to 0, and negative x if x is less than 0, when x is non-negative. When x is non-negative, the function simply returns the number. When x is negative, the function returns the opposite of x. Here's a little example. Complete the input-output table for f of x. -8 it's going to be 8. -4, the absolute value of -4, x is less than 0, so it'll be +4, the opposite of -4. 0, the absolute value of 0, when x is greater than 0, then it's x. 4, the absolute value of 4, well, x is greater than 0, so it is 4. And 8, the absolute value of 8, x is greater than, 8 is greater than 0, so we'll just go with x. All right. Use the plots you found on the coordinate grid. You plot the points you found on the coordinate grid. So we've got -8, 8, so that's going to be right there. And -4, 4, -4, 4 is going to be right there. 0, 0, 4, 4, and 8, 8. And we'll do a little graph here. And we'll go that way. And there we go. Now examine your graph of f of x equals the absolute value of x and complete the following statements about the function. F of x equals the absolute value of x is symmetric about the y-axis. Y-axis. Because look, you got a 4, -4, 8, -8, and therefore is an even function. The domain of f of x equals the absolute value of x is -infinity to +infinity, or the set of all real numbers, or the set of all real numbers. The range of f of x equals the absolute value of x is going to be 0 to +infinity, or the set of all, or the set of all, that looks like it, all non-negative real numbers. Good. And we'll go, let's see here. The domain, see, it is the x values, and it covers all of them. It'll eventually get on. The range, the range started here at 0 and it went up. So that's why it's all non-negative real numbers. Reflect. Use the definition of the absolute value function to show that f of x equals the absolute value of x is an even function. In an even function, f of x equals, in an even function, f of x equals f of negative x for all x. And let's see, f of x equals the absolute value of x is defined piecewise. So there are two cases to examine. X is greater than 0 and x is less than 0. So f of x equals the absolute value of x is defined piecewise. So, and you saw that just a minute ago up here, right here. That's defining it piecewise. So this will equal x if x is greater than or equal to 0, and negative x if x is less than 0. So, well, I guess what we need to do is we need to see. All right, so f of x equals f of negative x. Let's try that. So f of x, we'll say f of 2 equals, well, the absolute value of 2, which is 2. And f of negative x, f of negative 2 equals the absolute value of negative 2, which is 2. So f of x equals f of negative x. Explain 1. Graphing absolute value functions. You can apply general transformations to the absolute value functions by changing parameters in the equation g of x equals a times the absolute value of 1 over b times x minus h plus k. Now, you've already seen this. You saw this in the last chapter. Remember what that did? Yeah, vertical, compress, or stretch, S-T-R-E-T-C-H, stretch. And remember, it could also reflect over x-axis. Over x-axis if it was less than 0. Now, what did B do? What did B do? What did B do? That was a horizontal compressor stretch. And it could reflect, if it was less than 0, it could reflect over y-axis. And then H, what did H do? H, horizontal translation, left to right, and then K, I'll put K over here. K was a vertical translation, up or down. So you've seen all of these, and just like they had the same spot that they did in chapter 1. So given the function g of x equals a times the absolute value of 1 over b times x minus h plus k, find the vertex of the function. Use the vertex and two other points to help you graph g of x. So we have g of x equals a. I'll let you do a, and then when you come back, we'll do b together. Glad you're back. G of x equals the absolute value of negative 1/2 x plus 3 plus 1. So what is h? H is negative 3. What is k? K is 1. What is a? Well, I'm not seeing anything out here in front, so a must equal 1. A equals 1. And what about b? That negative. What is that negative going to do? So b, remember it's 1 over b, so b is, negative 2. Okay? It's negative. So what is, let's see, the vertex of the parent absolute value function is at 0, 0. G of x is a translation of f of x, and we could say 3 units to the left and 1 unit and 1 unit up. The vertex of g of x will therefore be at negative 3 and 1. Negative 3 and 1. Next, determine where the points 2, 2 and negative 2, 2 on the f of x will be mapped. So let's see here. We're going to find, let's do it here in black. Negative 3, and that's negative 2, negative 3, and then 1, that's going to be right there. So that's going to be right there. And let's walk through this here. Since the absolute value of b equals 2, g of x is also a horizontal stretch. Horizontal stretch of f of x, and since b is negative, a reflection across the y-axis. The x-coordinate will be reflected in the y-axis and stretched by a factor of 2, then moved 3 units to the left. 3 units to the left. The y-coordinate will move, up 1 unit. So 2, 2 becomes, and we'll say, I said negative 2, and then the original was 2, 2, minus 3, minus 3, and then 2, that was supposed to have been, no, 2 plus 1. Okay, so what do we got here? Negative 2 times 2 is negative 4, minus 3 is negative 7. That's negative 7. And 2 plus 1 is 3. So we get negative 7, 3. And negative 2, 2 becomes, well, let's see, we're going to have negative 2 times 2 minus 3. And then we're going to have 2 plus 1. So what is that going to give us? Negative 2 times 2 is that was supposed to be negative 2 there. Negative 2. Negative 2 times negative 2 is 4. 4 minus 3 is 1. And then 2 plus 1 is 3. Now plot the 3 points and use them to sketch g of x. So let's go back here. Let's go, where was it? Back here. And so that was our vertex. And then we had negative 7, 3. So that's negative 7 is there. And then 3, 2, 3. And then we had, what was the other one? The other one was 1, 3. So find 1, and then 3 is right there. And there's your graph. And it's going to look something like this. And there you go. All right. Your turn. Given g of x equals negative 1/5 times the absolute value of x minus 6 plus 4, find the vertex and the other 2 points and use them to help you graph g of x. Well, first, I guess, let's see here. A, what's A? Negative 1/5. What's B? B is, B is 1, so it's not going to have anything. H is negative 6, and K is 4. So our vertex will be negative 6, and 4. So negative 6, let's see, that must be 4, so that's negative 6 and 4. That's going to be right there. Let me use black for that. That's going to be our vertex. Now that we got to find those other points. So 2, 2 is being translated. So you're going to have, B is 1. So it's going to be 1. It's going to be 1 times 2. And then you've got minus 6. That was supposed to be blue. Minus 6. And you have negative 1/5 times 2 plus 4. So what's that going to give you? Negative 1, or 1 times 2 is 2, minus 6 is going to be negative 4. Negative 4, right? Let's see, 4. And then negative 1/5 times 2, that's going to be negative 2/5. And that's 20/5, right? That's 20/5. Make it all fifths, 20/5. And that's going to be negative 2/5. Negative 2/5. So that's going to give you 18/5. 18/5. And 18/5 is what? What's 18/5? Well, that would be 3 and 3/5. Okay, so negative 4. Negative 4, let's see, it's negative 4, and then that's 4, 3 and 3/5 is going to be a little bit less than that. Okay, Now let's try the other one. Let's try, well, we got -2, 2. So we're going to have what? We're going to have 1, or b, times -2, -2, -6, and then we're going to have -1/5 times 2 plus 4. And what is that going to give us? Well, it's -2. That's going to give you -8. All right. And then we've already done this right here before, and it came out with 18/5, which is 3 3/5. So we find -8 and 3 3/5. It's going to be right there. So our graph is going to look something like this right here. And there we go. Not too shabby. Explain 2. Writing absolute value functions from a graph. If an absolute value function in the form g of x equals a times the absolute value of 1 over b times x minus h plus k has values other than 1 for both a and b, you can rewrite the function so that the value of at least one of a or b equals 1. When a and b are positive, a times 1 over b times x minus h equals a over b times x minus h, which equals a over b times x minus h. When a is negative and b is positive, you can move the opposite of a inside the absolute value expression. This leaves -1 outside the absolute value symbol. So -2 times 1 over b equals -1 times 2 times the absolute value of 1 over b, which is -1 times 2 over the absolute, or -1 times the absolute value of 2 over b. When b is negative, you can rewrite the equation without a negative sign. Because of the properties of absolute value, a times 1 over b times x minus h, and a times the absolute value of 1 over b times x minus 1 over negative b times x minus h, this case has now been reduced to one of the other two cases. Example 2. Given the graph of an absolute value function, write the function in the form of g of x equals a times 1 over b times x minus h plus k. All right, let a equals 1. I'll let you do that one on your own, and when you get back, we will do b together. Let b equal 1. Let b equal 1. The vertex of g of x is at, well, we'll say, looking over here, we're going to say 1, 6, right? So this is going to be, oh, I didn't do that. That's what. So we got 1, 6, and this is going to be 1, and that's 6. I'm color coded. This means that h is 1 and k is 6. Okay, so you got g, let me do this like this. G of x equals, and we got a times the absolute value, and that's going to be plus k, and that's going to be 1 over, and that's going to be b, and we got x minus, and then whatever h is. So as you can see, we've got half of it right there. So substitute these values in the g of x, giving g of x equals a times, and that's going to be x minus 1 plus 6. Now choose a point on g of x with integer coordinates. let's use, well, they've already highlighted 0, 3, so we'll use 0, 3. So since it marked it, we'll use it, 0, 3. Substitute these values into g of x and solve. And solve for a. Okay, so we have g of x equals a times x minus 1 plus 6. So, and you see right here, we got a 3. The y is going to be 3, so we'll put a 3 here. Equals a times, and we got the 0 here. So this 3 came from there. And this 0 here came from there. All right. So this is going to give us a times the absolute value of 0 minus 1, which is a times the absolute value of negative 1 plus 6. We got the 3 there. And then we're going to subtract 3 from both sides, or subtract 6 from both sides, and we get negative 3. And the absolute value of negative 1 is 1, and a times 1 is just a. Therefore, g of x equals negative 3 times the absolute value of x minus 1 plus 6. All right, not bad. Let's try one. Why don't you stop the video, try it, and then when you get back, we'll do it together. All right. So what do we look? We got this point right here. That's our vertex. What is that point right there? What is that point right there? So that's negative 4. That would be negative 6. So that's halfway. We're going to say that is negative 5. And let's see, if this is 2, and if that's 0 and that's 2, that means that must be 1. So we have a vertex. We have a vertex of negative 5, 1. So let's just go ahead and we'll set our equation up. G of x equals, that's going to be a times the absolute value of 1 over, and then that's x minus, and then plus absolute value. So we're going to put our b here, and then we got x minus h, and then plus k. All right. Now, what did it tell us just a second ago? It says b equals 1. So that made it easy. We'll make that a 1. All right. So that just kind of goes away because 1 divided by 1 is 1, and 1 times anything is whatever that was. Look over here. We got negative 5. So we're going to take this h out, and we're going to put a negative 5 there. And we got 1 for k. So let's take the k out. And there we go. All right. So what are we missing? Well, we're just missing the a. Okay, that's all we're missing. And I'm looking, and there's this look right here, and that's halfway. So that looks to be 0, 9, right? That's 0, 9. So let's use that point. Let's see, choose 0, 9. And it doesn't matter. You could choose another point. It would still work. But we'll choose 0, 9. So this 9, that's going to be 9 equals a times the absolute value of plus 1 here. And negative 5, x minus negative, that's going to be plus, right? Well, what is x? X is 0, so we got 0. Change colors. 0, and then that's going to be plus 5. Okay? Plus 5. Plus 5. Because negative 5 is plus 5. All right, good. Now, so 9, we got a 1 here. Well, if we subtract, that's negative 1. That's down below, so that's -1. So this is going to be -1, -1. That means that was -1 to begin with, -1. All right, so let's add 1 to both sides, and that's going to give us 10 equals A times the absolute value A times the absolute value, and 0 plus 5 is 5. So we'll put 5. Well, the absolute value of 5 is 5, so now we're going to have 10 equals, and we'll say 5A. Well, if we divide both sides by 5, we're going to get 2 equals A. Did I mess up? Let's see here. 2 equals A. Given, write the function as A times. Okay, no, I didn't mess up. So what do we got here? So we have g of x equals, that's going to be 2 times the absolute value, and we've got x plus 5 minus 1. Okay, here we go. And modeling with absolute value functions. Light travels in a straight line and can be modeled by a linear function. When light is reflected off a mirror, it travels in a straight line in a different direction. From physics, the angle at which the light ray comes in is equal to the angle at which it is reflected away. The angle of incidence is equal to the angle of reflection. You can use an absolute value function to model the situation. Example 3. Solve the problem by modeling the situation with an absolute value function. At a science museum exhibit, a beam of light originates at a point 10 feet off the floor. It is reflected off a mirror on the floor that is 15 feet from the wall the light originates from. How high off the floor of the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? So they gave us a nice little drawing here. Good. And what do we got here? Identify the important information. The model will be of the form g of x equals a times the absolute value 1 over b times x minus h plus k. All right. Now, the vertex of g of x is, well, what's the vertex? What is this point right here? This is going to be your vertex. Well, it says that's 15 feet. It's not, so that's going to be 15, 0. Okay? So the vertex is going to be, and I'm going to color code this. That's going to be 15. So that's going to be 15. And that's going to be 0. So 15, 0. Kind of keep it consistent. Another point on the line, another point on g of x is, well, this point right up here, right here, and that's 0, 10, right? So 0, 10. The opposite wall is, and let's see, 15 plus 8, that's going to be 23.5 feet from the first wall. Let the base of the first wall be the origin. You want to find the value of g of x at x equals 23.5, which will give the height of the beam on the opposite wall. To do so, find the value of the parameters in the transformation of the parent graph. In this situation, let b equal 1. The vertex of g of x will give you the values of, let's see, h and k. Use a second point to solve for a. Evaluate g of, and this is the point that you're looking for over here, right? So you're going to want to solve for g of 23.5. So the vertex of g of x is at, that was 15, 0. Substitute, giving g of x equals a times x minus 15 plus 0. All right, evaluate g of x at, well, we're going to evaluate it at 0, 10, and solve for a because that point is known. So you got 10 equals a times, and that's 0 minus 15 plus 0. Right, and that's your h right there. All right, so 0 minus 15, that's going to give you negative 15, and bring the 10 down. And the absolute value of negative 15 is just 15. All right, and so 10 divided by 15, that's going to give you a equals 2/3. And I put that in red because that's the color I've been using. Therefore, g of x equals 2/3 absolute value of x minus 15, and then you can write plus 0, just leave it off. So we want to find g of x is 23.5. So g of x is 23.5. So let's see. G of 23.5 equals, and that's going to be 2/3 times the absolute value of that. That's going to be 23.5, and then we got minus 15. So g of 23.5 equals, that's going to be 2/3. 23.5 minus 15, 23.5. I get it. That's the absolute value of 8. Let's see. 23.5 minus 15 is 8.5. So it's going to give you 8, absolute value of 8.5. We could change that into a fraction. 8.5, that would be the same as 17 halves. Let's see here. 8.5, control, divide, menu, 2, 17 halves. So 17 halves, so g of x, or g of 23.5 equals, well, it's going to be 2/3 times 17 halves. Well, the 2's cancel out, so you're given 17/3. So that's going to be 17/3, which is approximately 5.67. Justify and evaluate. The answer of 5.67 makes sense. 5.67 5.67. Makes sense because the function is symmetric with respect to the line y equals 15. The distance from this line to the second wall is a little more than half the distance from the line to the beam's origin. Since the beams originates at a height of 10 feet, it should hit the second wall at a height a little over 5 feet. Your turn. Two students are passing a ball back and forth, allowing it to bounce once between them. If one student passes the ball at a height of 1.4 meters and bounces it 3 meters away from the student, where should the second student stand to catch the ball at a height of 1.2? So here we go. And then we got one student, and he's got a basketball here, and we'll say this is bounce passes the ball from mine. So this is 1.4 meters, and he bounces 3 meters away from the ball. Bounces the height, and it bounces 3 meters away from the student. So it's gonna go, and we're going to say this is 3 meters, and so we're going to say this is 0, right? And where should the second student stand to catch the ball? So the second student is, and we don't know what that distance is, but we got a second student standing there. And he is ready to catch the ball. And he's not as tall as the other one, so he's only, this is 1.2 meters. And that's 1.4 meters. So where should he stand to catch that ball? Okay. Well, let's see. Let's let A equal 1. So let's let A equal 1. And so what is our vertex? What's our vertex going to be? What's our vertex? Well, we're going to say 3 and 0, okay, because that's this point right here. That's our vertex, 3, 0. That almost looks like 10, doesn't it? I mean, I can do better than that. 3, 0. That looks better. So that's our vertex at 3, 0. So what do we know? What do we know? Well, let's use this point here, 0, 1.4. Okay, let's use this point 0, 1.4. Or 1.4, that would be the same as 7. So we're going to use the point, and we'll say 0, that's the 0 on the x there, 0, and 1.4, or I'm going to use a fraction, 7/5. 7/5 equals 1, 7/5. All right. So we got 7/5. We got this point right here. So we've got 7/5 equals, and we already said A is 1, so we got 1 times the absolute value, and then we're going to have 1 over B, and this is 0 on the x-axis. That's 0 on the x-axis. So we'll put 0 minus, what h is 3, right? H is 3, so we're going to put 3 there, close parentheses, and the absolute value, and then of course you got plus 0, plus 0. All right, now let's solve that. So we got 7/5. We're trying to find out what B is. We got everything else. 7/5 equals, well, the 1's going to go away, so we got absolute value of 1 over B, and then 0 minus 3, that's just going to be negative 3. That's going to be negative 3. All right, absolute value. So we can do a little thing here. We got 7/5 equals the absolute value of negative 3 over B. And let's use it. B. Well, what's the absolute value of negative 3 over B? It's going to be 3 over B, right? So we got 7/5 equals 3 over B. So let's see, we'll do a little cross multiply, and we'll take that up here, and we've got 7b equal, and 3 times, it's going to be 15. Let's divide both sides by 7. You got 15 over 7. So B is 15 over 7, right? So our equation is going to be g of x equals, well, 1, we'll just leave it off. We got the absolute value, and that's going to give us x minus, oops, about to forget something. We've got 1 over 15 sevenths, so that's going to give us 7/15 times, and then it's going to be x minus 3. Okay. Now we know this is 1.2, but we don't know what that is right there. That we don't know what that x is. So we're going to put in 1.2. What is 1.2? Let's go, and 1.2 menu 2, and that gives us 6/5. So we got 6/5 equals the absolute value of 7/15 times x minus 3. All right. Now, that's just going to be absolute value. So we're going to have 6/5 equals 7/15 times x minus 3. So that's 6/5. We're going to, what did I write? Oh, we're going to multiply both sides by 15 over 7, and I wrote it again. I can't, there we go. So let's see, 6/5 times 15 over 7. So that's going to give me a 3. It's going to give me a 1. So that's going to be 18 over 7. So I got 18 over 7. 18 over 7 equals x minus 3. Well, if we add 3, that's going to be, add 3, that's going to be 3. That's going to be like 21 over 7, right? So what do we got here? 21, that's going to be 39 over 7 equals x. Okay, so if x equals 39 over 7, that's going to be 39 over 7 goes into that. Let's see, 5. That's going to be 5.5 meters. So, and that kind of makes sense. So it's going to have to be about 5.5 meters away. Okay, 5.5 meters away. Elaborate. In the general form of the absolute value function, what does each parameter represent? Well, let's see. H is the horizontal translation. Horizontal translation. Translate left or right. And then K is the vertical translation. And we'll say up or down. And then A, what does A do? A is a vertical stretch or compress. And it can also reflect over the x-axis. And B is going to be the horizontal translation or horizontal stretch or compress. It can also reflect over the y-axis. Number 6, explain why the vertex of f of x equals the absolute value of x remains the same when f of x is stretched or compressed, but not when translated. Well, the vertex of f of x equals the absolute value of x is at 0, 0. So what happens when you multiply something by 0? It stays 0. So that's why the vertex doesn't change. Because the vertex is 0, 0. And anytime you multiply something by 0, you get 0. Essential question check-in. Now, what are the features of the graph of an absolute value function? Probably the most significant, let's see, the features are the vertex, the direction of the opening, and the slope of the ray. Excellent job, folks. See you tomorrow in class, and you have a great evening.